Earth survives only because its distance from the sun never stays the same, and if that motion stopped, the planet would fail. Earth does not sit at a single perfect distance from its star. It never has. Earth orbits the sun along a gentle ellipse. Over the course of a year, it moves millions of miles closer, then millions of miles farther away. At its closest point, about 91 million miles. At its farthest, about 94 million. When people say 93 million miles, they are naming an average, a midpoint between extremes. And that detail matters, because Earth does not survive by being fixed in space. It survives by constantly moving through narrow margins without crossing them. Astronomers describe a region around stars called the habitable zone, a range of distances where liquid water can exist on a planet's surface. But this zone is not a guarantee. It is not a promise. It is a pressure range. Within it, a planet still has to work to stay alive. Earth does not cruise comfortably through this region. It skims it, remaining habitable only because internal systems absorb variation and correct instability before it escalates. Most planets do not have those systems. As Earth moves closer to the sun, solar energy increases. Temperatures rise slightly, ice melts marginally, oceans absorb heat. Atmospheric circulation redistributes it. Nothing dramatic happens because Earth can buffer the change. But buffering has limits. If Earth's average distance were only slightly smaller, not seasonal motion but permanent proximity, heat would accumulate. Warmer oceans would release more water vapor. Water vapor is a powerful greenhouse gas. More vapor traps more heat. More heat drives more evaporation. The feedback reinforces itself. This is how planets lose oceans, not violently, irreversibly. When Earth drifts farther away, solar energy decreases. Temperatures fall. Ice spreads. Ice reflects sunlight. Reflection reduces warming. Cooling accelerates. Again, Earth compensates. To a point. Ocean currents move heat. Atmospheric gases retain warmth. But beyond a threshold, the feedback reverses. Ice expands faster than heat can circulate. The planet locks into cold. Earth has entered near global ice states before. It escaped only because volcanic activity slowly replenished greenhouse gases. That recovery took millions of years. Life endured at the edge of survival. There was no margin. Distance from the sun does not create life. It defines how difficult survival will be. Venus receives only modestly more sunlight than Earth. Mars only modestly less. Yet Venus is hot enough to melt lead. Mars is cold enough to freeze its atmosphere. Distance establishes conditions. Survival depends on response. Earth responded with balance. Earth's atmosphere is not a shell. It is a flow. Solar radiation continuously energizes its upper layers. Some particles gain enough velocity to escape gravity entirely. Earth loses atmosphere every second. It keeps enough only because gravity slows the loss. If Earth were smaller, this balance would fail. Mars once had rivers. Now it has dust. Atmospheres are not permanent. They are maintained. Earth's gravity is often taken for granted. It should not be. Slightly stronger gravity would thicken the atmosphere. Pressure would rise. Weather systems would intensify. Biology would face constraints it may not survive. Slightly weaker gravity would thin the air. Water would escape. Radiation would penetrate. Earth exists inside a narrow gravitational window where air, water, and chemistry can coexist. That window closes easily. Earth is constantly struck by charged particles from the sun. Without deflection, they would strip the atmosphere molecule by molecule. Earth's magnetic field redirects enough of them. Generated by motion in the planet's liquid outer core, this field creates a protective bubble. But it is not constant. It weakens, it shifts, it reverses polarity. This has happened many times. During reversals, radiation penetrates deeper. Life survives because the field does not vanish entirely, and because change is slow. Mars lost its field. Soon after, it lost its air. Earth's moon is unusually large relative to its planet. This stabilizes Earth's axial tilt. Without that stabilization, Earth would wobble chaotically. Sunlight would shift unpredictably. Climate zones would migrate violently. Ecosystems would not persist long enough to complexify. The moon also governs tides. Tides mix oceans. They distribute nutrients. They prevent stagnation. This influence is mechanical, not aesthetic, and the moon is slowly moving away. Earth rotates once every 24 hours. That rotation spreads solar energy across the surface. Slower rotation would create permanent heat and permanent cold. Faster rotation would intensify storms beyond survivable thresholds. Earth's rotation has changed. It continues to change. Survival depends on rate, not permanence. Water absorbs heat efficiently. Oceans store energy and release it slowly. This buffers temperature swings, but oceans must circulate. Currents move heat from equator to poles. Disrupt that circulation, and regional climates collapse. Evidence of abrupt climate shifts is written into Earth's geology. Stability is conditional. Early Earth had almost no oxygen. Oxygen was toxic. Life changed that. Photosynthetic organisms released oxygen as waste. Over time, ozone formed, radiation decreased, complex life expanded. But oxygen is reactive. Too much and ecosystems burn. Too little and they suffocate. Earth's chemistry remains stable only because biological, geological, and atmospheric cycles remain synchronized. That synchronization is fragile. Earth did not rush. It took billions of years to reach habitability. Rapid change kills. Static systems stagnate. Earth survived because transformation occurred within survivable limits. Time was not a backdrop. It was a constraint. Most planets fail early. They lose air. They lose water. They lock into extremes. Some stabilize in lifeless equilibrium. Others never stabilize at all. Earth is rare, not because life appeared, but because balance endured. And endurance is temporary. Earth does not rest on a wide foundation. It balances on interacting limits. Change the distance. Change the gravity. Change the field. Change the chemistry. The system does not negotiate. It breaks. Earth survives not because it is perfectly placed, but because it remains within narrow limits while constantly moving. Its balance is dynamic, conditional, borrowed. When those limits are crossed, there is no adjustment period, only consequences. And the universe will not slow down to accommodate life.